Okay, I'm good to go. If everybody else is good to go.
Think you're good to go. Thank you.
Try and find the chat window as well. No, that's not the chat window.
I'll pass along any chat stuff.
Okay, yeah, it's far too complicated to do anything like that.
Yeah, WebEx it can be hard when sharing. So
yeah, the WebEx utility that has the capability to do online subtitles is really, really powerful. Okay, so let's get started. We're going to talk about change data capture. Well, there's my contact details. A lot of people know them by now. So anyway, what we're going to do is talk about change data capture. And before we do that, I want to just say what we're going to look at. We're going to look at the log files first, because that's really what change data capture is built on top of. We're going to have a quick look at onlog, and then we're going to move into change data capture itself and, well, basically see how you use it. We'll be using the demo code for a large part that comes with the engine, and it'll be, as always, a mixture of pseudocode, real code, and very, very little error handling. This is based on my experience using these various utilities. I'm happy to be proved wrong. If anybody has any doubts or any questions on what I'm saying. Simple thing, we all know the logical logs, just a set of records, correct, saves all the changes made to the database, it's used for recovery, etc., etc. Okay, so there's no rocket science there. We all hopefully know what logical logs are. Now, onlog can be used to display and interpret the logical logs. Onlog is just a viewer. It cannot make any changes, and despite some of the error messages, it can't be used to make any repairs. So what I'm saying there is you will see these errors occasionally. An assert file, use onlog to view the transaction and repair manual. It's one of IBM's worst messages. It's absolutely meaningless. You can't actually repair it. You need to call IBM. What it really should say is contact IBM tech support because you're in real trouble now. So I'm going to rattle through these onlog slides relatively quickly. It's a subset of a presentation I've done multiple times over the years. So onlog ships with the engine. It can do a variety of things. It can open up the logical logs, either the ones on disk currently inside your DB spaces. It can go out to a tape device. You can filter based on user information, table space information, transaction number. The one that came in recently, a new addition, is a compression dictionary, which you have to do some secondary processing to get that compression dictionary out so onlog can actually use it. So when you run onlog, what you tend to see, or what you will see, is the logical log record header. Every logical log has a header, okay? And it will display a portion. The standard onlog will display a summary of each logical log record. And what we've got here on the screen is an address where the logical log record is existing, its length, what type of log it is, various other information on the screen. A large number of the types are documented. Not all of them are, but some of them are. So what have we got in the header columns? We've got the address. So this is the logical log record address, sometimes known as the log position. We have how long the logical log record is. So each logical log has a fixed size header, and then it has additional records depending on what the logical log actually is itself. So a begin work is a relatively short one. An update could be huge. We have the type of record. Like I said before, most of them are documented. Most of them are fair, even the undocumented ones, you can normally have a good guess of what they actually do. We have a transaction ID. The transaction ID is the current transaction ID within the logical log record set. It does not relate back to transaction ID that you'd see on an unstat-x or anything like that. The only thing you know is that ID is unique at the time it's being run, but those numbers will be reused. So when you're looking through the logical logs, you might see transaction ID 99, and then you'll see a commit work, and then a couple of pages later, or a couple of records later, you'll see transaction ID 99 being used again. So you can't, it's not unique, it is reused. The backlink ID tells you whether you need to look backwards into a previous logical log to find the previous record. So if you are staying within the logical log record, it'll be 0. If not, it'll be the log ID that you need to go back to. And the link will be the log position of the previous transaction. Okay, so what we've got here is an example highlighted in red. So red is the log position. Okay. It is built up of the logical page offset within the log and the byte offset on a page. That is unique across the lifespan. No, sorry, ignore that. No, I'm right. Sorry, that is, I believe, unique across the lifespan of the engine. You can see there that, well, we've got a. So I'm just reading my notes here. Sorry, this page I was after. So what we see here, we've got a link ID, an ID of 0. That tells us that we're in the current logical log. The link ID, the ID and the link together tells us where we need to go to find the previous record for this transaction. So we see here that we've got ID 0 and a link of 1E460. So we know we need to go back within this logical log to find that log record. Again, we're just looking at the header columns here. So we look at the log record listed here. We're starting at address 18. We're at address 18. Those of you know the page headers. We know that we're in hex 18, so we've allowed for the page header. The previous logical log record is in logical log 4 with that link address. If we jump down to the end and start looking at where it says 330 on the left-hand side there, we can work out how to go back in time or back in the logical log record. So we're at 330. We've got a link ID of an ID of 0 and a link of 120. So we go back in the same logical log to an address of 120, and we'll find the other records that's associated with this transaction. And from the 120, we can go back to ID 0, stay in this logical log record, and we're going to go back to address 18. So we're going back in time. We can use the same logic starting at 18 and move forward the number of logical logs, the record size based on the length. So basically just a reiteration what we're seeing. So this is how we read forward and how we read backwards. We just discussed, and you can pull up the logical log records, and you can use this information to transverse the logical logs in either direction. So I've got an internet delay here. There we go. The LSN, this is what we talked about earlier. It's unique across the entire engine lifespan. So you will never see the logical sequence number repeated. It identifies a position with the logical log. So that logical log sequence number, the LSN, could actually be out on a logical log that you've archived out to disk. It's been deleted as part of your normal archive process because it's no longer needed, etc., etc. But it is unique across the lifespan of the engine. And you see here we've got unique ID 14, we've got an address, and that combined will give us the LSN 14.0.2018. Like I said, that is unique across the lifespan of the engine. That becomes important when we start looking at change data capture. There's a variety of record types. They keep documenting more and more of them. The common ones you'll see, begin and commit, obviously. They will give you a timestamp. The only records that are timestamped that I'm aware of are begin and commit work. The only record that has user and session information is the begin work. So we get a timestamp on the begin and the commit, but we only have user information based on the session ID we only have the session ID in the begin record. H insert, home row insert, it will insert data into a page, and it will tell us in the additional information, the table space, the ID, the row ID, the slot length, etc. Add an item, adds an item into an index. H delete, del item, obviously they're delete ones. As I said before, normally you can work out what the record is doing based on having a guess at the name. Challenge free, obviously we're doing something with chunk allocation, chunk freeing. PT extend, we're adding space to a table, and we'll see an example of that in a little bit. C index, create an index. Erase, we're dropping a partition. Build CL, we're building a partition. Like I said, most of these are documented, and most of them that are documented, or ones that are documented, it will give you an explanation of what the additional record or data is in that logical log. So if you look up the begin work in the manual, it will tell you the header information, and then it will detail the date, time, SID, user, and where they are within the record. So what we're going to do is quickly look at what we see in the logical logs. So we're going to create a table, and we're going to have a look and see what physically appears in the logical logs. Obviously, we've got some information here. Simple table, whiskey, a few columns, a few indices, and a delete. So we're going to look at the insert and what physically happens in the logical logs. Like I said there, we can see the very top line, we've got a begin, we've got a timestamp. Oh, that's an old slide. And for reasons best known to me, I've done this as root. So I should burn in the pit of hell. So if you look at the H insert record there, we have the part number, so we know what we're inserting into. So you can go off into your system tables and find out what that table is. We have the row ID that we're inserting into, and we'll have a slot length of 34. If you look back up to here, we've got 34 because we got an integer, we've got a char 20, and we've got a char 10, and in my maths that come out as 34. The red lines there, we're doing an H insert, we're adding an item. We're adding the item into an index. We know that the detached indexes, because they've got different part numbers, we know the row ID again, and we have information about the key, the length. So we know 4 is the integer index, we know 20 is one of the char indexes, and we know 30 is the other char index. And then we've done a commit. So we've got the entire transaction record that we need held there, and we can parse that or process that however you see fit, and we'll come into CDC later and find out how CDC does that. Similarly, if we want to do a delete, we've got a begin work again. We're deleting, we can see what row we're deleting from, what table we're deleting from, the slot length we're deleting. and then we del items, so we're taking out the index as well. It's very much the same as the insert record. It's just obviously reversed. We have to release the slot from the page. We have to remove the index from the index page. What you can't use onlog for is to fix things. You just don't get told enough in the manual. You can get some strange page changes as you're jumping around the logical log records. You rely on the length and the record that you're looking at, but I have seen situations where you think you have to jump forward 30 bytes and you jump forward 30 bytes and you end up with something that doesn't make any sense whatsoever. Also, if you have got an update that is greater than a single page, then you have to be able to track across the page boundaries. So you have to be able to move forward 6,000 bytes, but that's across multiple pages. So you have to allow for the page header and the page trailers to make sure that you end up in the right position on the next page. If your table has changed, so if you imagine you've got a table that is an integer, just a single column integer, so that's fine, that's your standard byte size, and you change that to 2 small ints, unless you're tracking the DDL, you have no idea that has changed. What I mean here, what we just talked about, so the partner will still be the same, the logical log record will still look the same, but how you'd map those 4 bytes into your table structure is completely different. Again, if you imagine you've added, changed the size of a char and the total byte length of the record is the same, but the actual raw data to column mapping will be completely different. So you got to, when you're looking at these things, you've got to know what's happening. So we've looked at onlog very, very briefly. Before we move on to the next bit, has anybody got any questions so far? If I'm going too fast, too slow, just let me know. Anything, Tom?
Nothing in the chat right now.
Oh, that's not a good sign. Okay, so let's start looking at CDC. From the fine manual. Okay, so it's changed, capture, etc., etc. You can read the screen as well as I can. It tracks data modification. So insert, delete, update, truncate. Okay. It abstracts the logical log from you and in theory makes your life a lot easier with some predefined functions that you call with inside your application, which will start processing the logical logs for you. The big one there, change data capture, does not capture any changes to database schemas or any other database changes. So if you do any sort of DDL, it will not be in it cannot be reported by CDC. It has been an RFE a few times and it's always been rejected. If you attempt to alter table that you have data capture active on, you will get an alter process fail like you would on a normal replica. If you've got a table defined for replication and you try and make an alter table on it, you'll get this table's being marked for replication. So what you'll see in error, one obviously, you can only change data capture, will only capture data that has been logged, obviously. So change data capture here, I've got a table, Eric, a database, Eric. I've tried to alter the table. It's come back. I can't perform this operation, define a replication, on check minus PT, and it will tell me table space is flagged for log snooping. If you're using smart triggers or replication, you will get similar sort of messages as well. If you're coming back up to here, it says in the middle there, you cannot go backwards in time through the logical logs to capture history of the table. That is absolute rubbish. I don't know where that came from, whether it's a fault in the manual or a change in the API. But here's an example here. So I've inserted it into a table, a current date timestamp. I've looked at that. You can see the current in green there. You can see the current logical log position, 9727. And I've said, I want to go and use change data capture starting at log 9724. And I want to know what's happened on this table. And you can see there the date of the machine and the date of the records changed. I have gone back in time and I have looked at things historically. So as I said, I don't know if the manual's wrong or we've increased the functionality at some point. But you can definitely go back in time. Luckily for us, there's only, 7 functions that we need to worry about, and we will look at all of these, but most of them is fairly obvious what we need to do or what we're doing. We're opening a session into CDC. We have to set full row logging, so we have to make sure that all changes that are going to the table, we're logging every column. We have to start a capture, we have to activate it, we have to end it, we have to turn logging off maybe, and we have to close the session ID. Session ID isn't a session ID within CDC. It doesn't bear any direct relevance to OnStatManageG's session. Okay, I'm using a lot of time. This is an adapted version of the demo program that ships with the product. So I'm going to run CDC. We call CDC on in it, obviously. I'm looking at a table, Paul CDC. It must be owner prefixed. And then I'm going to list the columns I want to look at, and I want to where I want to start my logging from. So again, we're looking back at that logical log, 0x. So I'm looking at I want the first record. And we see there, it's going to start the snooping, and if we're connecting to the CV1 database, which I forgot to mention earlier, it's something you have to create. There's an SQL script down in ETC that will create the database for you. So the first thing we want to make sure is we've got full logging turned on. So within your code, you need to execute the function CDC, set full logging on, and you have to specify the database, the owner, and the table, and 1 means turn it on. Ignore some of the full on, etc. That's just debug within the code. And then we have to open a session to tell CDC what we want to do. So we're going to open session to the Infomix server. A variety of parameters there. They're documented. Basically, timeout is the 300. The 1 and 1 at the end are mandatory things. I don't think you can change one of them. It's in the manual. It specifies what version of the CDC, sorry, the CDCV database you're using. And it will return a session variable, 129, etc., etc. So now you've got the session active, you have to start the capture. And you start the capture based on the session ID, again, the table fully qualified, the columns you want to look at. I don't know why it's got tab number in there. Oh, sorry, tab number in there. Tab number is not tab ID. So when you're capturing, you can specify to capture multiple tables. So I could have, in the demo code, it's hard coded to 10. So I could capture up to 10 tables. And that tab number is an index into an array, a structure array that tells me Paul CDC is being tracked within the structure at array position tab num. So it's not the same as a tab ID. So we've now got an active session. We've started the capture. Okay. we start the capture. Now we have to activate the session. We pass in the session number and the LSN. So we pass in where we want to start looking from. So now we're reading the logical logs. So what the engine has done for us is passed back the session ID variable, that 12 very long number we saw earlier. And then we're going to use a large object read. So while condition true, we will read bytes until basically we run out of bytes. If we get a large object read error, we've got a problem. There's something wrong with the actual read function. So now we have to step through the logical logs that are coming back, the byte data that is being returned to us by the low read. And if we have data, we have to do something with it. We also have a built-in timer into the back end that we saw earlier was set to 5 minutes, 300 seconds. So if we hit 300 seconds of inactivity on the tables we're capturing, the engine will send us a timeout status, and we have to act accordingly. So the key there is we read the bytes, okay, and then it's up to us what we do with those bytes. We have to handle the error trapping around that. So generally, I've got a function there called doIt. I'm passing in the pointer of where we are at the moment. So I've got bytes read. I am tracking where I am within the structure coming back. I pass that into a function called doIt. And in doIt, we have to work, obviously, what we're going to do with it. So you call doIt, we have a record pointer. We can take that record pointer and get a log type. So the engine will return us a byte position, and within that first part of the byte position, we'll have a current log type. And the ones that I'm aware of are listed there. So we've got a begin work, a commit work, a rollback, insert, delete, update, before, update, after. So we've got before and after images. We have a discard, we have a truncate. We have a special one called tab schema, which we'll come on to in a minute or two, and we have a timeout. So those are the records that will be returned. Obviously, in the switch statement, you want to make sure that if you get none of those, you're going to have to break out or error out in some way. Otherwise, you're going to be stuck there forever. Examples of the log type record and things like that are in the demo code, so you could actually have a look and see how it achieves that and gets that information. The one I didn't know about until recently was a discard record. I had to go and look up and find out what that actually does. It's not logic I've ever used. I've never used save points in the real world. So what we've got here is we do a begin work. We set a save point of whoops. We do some work, and for whatever reason, we decide we're going to roll back to whoops. So what we would see in the logical log record, we'd get an insert in the logical logs at position 428. We'd get another one at position 444, the top two red lines. And then when we roll back, we will get a CDC discard record telling us to go back to 0x28 and ignore all the records we've received from that point to where we currently are. Like I said, it's not logic I've ever used. I've never used save points, so I had to go and look that up. So ignoring save points because I don't know enough about them, we'll move forward. So when you start reading the logical logs, you will get a tab, a CDR-rec tab schema, and that will tell you the record you've got coming back contains schema information. You need a structure defined to receive that, and those structures are documented in the manual. So you just have to create a structure as per what the manual says to receive the tab schema record. So it will give you the user data reserved. It'll tell you how many columns are fixed width, number of variable columns, etc. The main one, that it'll give you the column description. So it will tell you, it'll give you a structure or pointer to a structure that will allow you to describe the column that's been returned. Okay, so that's where we're getting a little further up in the screen there. We're getting C1 as a serial, C2 as a date time, etc., etc. That is coming from the call description. I believe that record, I've only ever seen that record return once per table. So I'm guessing there's some magic at the back end that stops that being returned multiple times. I don't know why or how that's done, but the only way it makes sense to me. So again, I said we're using the demo code here. So we've opened up the change data capture. It's come back with a CDC record of tab schema. We know the total size, 43. We know how many columns we've got. We know how many variable columns we've got. We know what the schema is for the table. That's come out of the column description. And what they do in the demo code, they create a table of exactly the same schema and compare using ESQL's describe. They compare the schema that is you're requesting is the same as the schema that is coming back from the call description. Okay, so again, using the demo code with some various tweaks, we can now look at what's happening coming back. So you see, we can take the record, we've got the LSN, so we know where we are within the file. We've got the transaction D, we've got a timestamp, and we can convert that record back into an SQL statement. So we can now know that we inserted into Paul CDC those 6 columns with those values. Now, when you specify the capture, we could have just said we want to look at C1, 2, and 3, and then we'd only get an insert statement that's relevant to 1, 2, and 3. And then we can see we've done another insert a little bit later. So we can now track and convert the record back into an SQL statement. Coming back to Mike's slide earlier, or Mike's presentation earlier, you can now tie this back into an audit record. So you can see from the audit record via, I said we use time series and Grafana. We can track down when somebody did the insert, and we can go and actually find out what they inserted. More particularly, we're generally looking for why somebody's deleted something. Same, you can do the same with an update statement. So you can, again, take the record, you know the record type, you know the column descriptions, you can convert the data that's in the logical log record back to human readable SQL statements. You can either do all of the columns in your set statement, or you can put some logic in there and only report the ones that have changed. It's entirely up to you. But by default, you will get everything that is in that update statement. Whether you want to push all of them through or not is up to you. If within your code, you know what the primary key is, you can adjust the where clause to only use the primary key elements. So your where clause could be, instead of set column 1, 2, 3, 4, 5, 6 to something where column 1, 2, 3, 4, 5, 6 equals a set of variables, you can convert that to update set the column I'm interested where primary key equals. But you have to code that logic into it yourself. So the default ish of the demo code, it doesn't give you what we got highlighted in there, a -L. So it tells you to start capturing from a point in time or point in LSN, but we can also tell it that when it gets to a certain LSN, it can stop. So coming back to Mike's thing earlier, we know somebody did something around about 12 o'clock, they deleted something. We can have a good guess of where that is within our logical log DB spaces. And we can say, right, fine, I want to start a logical log that I think is 11:45, and I want to go to 12:15, and just look at those for me. You can, with care, it's not on this slide, you could specify a time, and you could just scan from your first logical log all the way forward until we find a begin record with a timestamp that is relevant to where you want to start looking. And you could do the same thing when you want to time out. So we could, with care, say, look at the logical logs between 11:45 and 12:15 for this table. By default, the demo code does not understand a star for columns. So if you want to monitor a large table and you don't want to type in all the column names, you will have to code that into the system. It won't do that for you. And then you have a file if you want to dump out the log records. And again, this is in the demo code. Most of what you want to do will be in there. You just have to tweak it to make it work in your world. By default, when you read a CLOB, it will only read the first 2 gig of data, unless it crashes in the meantime. So what happens when you reach the end of the CLOB? You've got 2 real choices. You either exit your code with the last LSN that you're up to, and then you restart your program with the last LSN, or you have logic in your code that says, I've got to the end of my 2 gig, I need to restart my capture at a different LSN. It's entirely up to you how you do that. You just have to make sure you close down the sessions, close down the capture, restart the session, restart the capture. So you either do that by spawning or rerunning the code with a different starting point, or you put it inside your program and just let it run. It's entirely up to you. Okay, a couple of gotchas on change data capture. Before you start doing anything, check the CDC API example works. In FC7, it didn't. In 1DB 2 point something, it didn't. You can generally tell if it's misbehaving because the standard code will print out the string values of the data it's capturing. If the screen is mangled, you probably have a problem. Like I said, not all of them, the CDC APIs, seem to work across all engines. My starting point is make sure that works, make sure it gives you good data. Because the logical log records are stored in a network independent format for endians, you have to make sure that you are transforming the endians correctly. I think by default we use big. So double and float is stored in big. So we need routines that will convert them, if appropriately, to make sure that we're looking at the data the right way around. The LD 248 functions are within the demo code, but if you've already got code that will do that endian conversion for you, might as well just use them. You can only look at logical logs you can see from within the server. So if you have spawned something out to tape, you can't read it. None of the functions are valid within a UDR. This is a pure client application. I don't know what will happen if, I've never tried it, I don't know what will happen if you try and call these from inside a C-based UDR. When mentioning C there, all these functions are also available under Java. I don't do Java, so I don't know much about it, but the logic is very much the same. If you're capturing multiple tables, you have to make sure your client API can keep up with the amount of logical log traffic going through it. fairly obvious. It does not capture DDL. The engine must be online. If the table that you're capturing for doesn't exist anymore, so we want to go back and look at a table that has been dropped, we need logic within the application layer to work out what that schema was at the time it was dropped. Otherwise, we have no way of mapping the logical log record to the column listing. How many tables can you capture at a time? The demo code is hard-coded to 10. It's just a static array. I was chatting to a couple of people at IBM this morning. Brian's still on the call. He went off to the development team, and the development team came back and said there's no limit, which is obviously rubbish. There is a limit, but it's obviously not hard-coded into the code itself, so it'll be more down to server load. So if you want to capture 100 tables per time, per application, as long as the server can keep up and as long as you're not getting behind, it won't be a problem, or there's no problem we're aware of. My gut feel would be if you try and monitor, say, 32,000 tables or 32,000 sessions, we might hit an internal limit there, but according to the development team, there's no hard-coded limits into what the amount of data you can capture. Back in the dark ages, before CDC existed, we came up with a product called DBVoyeur. I'm only mentioning it's in passing. So we could run DBVoyeur on a system, and it would give us back what was inserted into a table. But what CDC can't do, it can't give you the DDL. So we got a table there, create table whiskey we saw earlier. If we look at the logical logs there, red, okay, we have to create some space for the table. So we have to allocate the table, we have to allocate some space to the table, and then we have to make the space that we allocated available by extending the partition. Now, CDC will not allow you to do this. Oh, sorry, that's not fair. CDC has no mechanism for you to grab that. And then when we've created the table here, so this is just created the raw table. We then have to add the columns, etc., etc. We're adding these into sys tables, sys columns. Interestingly, we add into sys columns before we add into sys tables, and you can see the data going through there. CDC will not convert that back to a statement like that. So we took the logical log records and we can say, go and find the DDL and pull the DDL out of the system. So we can go from the table create, index create, etc., etc. It can also read the logical logs from another system. So we had a couple of customers, they emailed us the logical logs they were having problems with and the relevant schemas, and we could take DBVoyeur and we could process their logical logs offline from their system and come back with what was happening on their data. This was a semi-live example. It was a banking application, and they were losing, or they'd lost some trades and they couldn't work out why. They emailed us the logical logs and their schemas, and we come back and showed that, well, these were the records that were inserted, and then a bit further on we could see that the records had actually been deleted as well. Now, that, I think, is all I've got. Yep, that's all I've got. I don't know if I've overrun or underrun.
No, you're perfect. So
I like to think so.
So couple of comments in the chat. First one is the wording saying you can't go back on the logical logs. It may it wasn't sure, but May Brian was mentioning that it's just to cover IBM in case you have logs that have rolled off.
Yes, no, I understand that. I mean, I think it's just badly phrased.
Yeah.
Like I said, the tool we started writing our DBVoyeur before CDC existed, and I remember being in a presentation or presenting the onlog thing back in something like 2008 or 9, and Madison being in the audience going, I think we can do this in the engine. And at that point, I stopped doing anything with DBVoyeur because CDC was going to be happening in the future. So yes, you're right. You can't go back. But CDC, you can't go back to a logical log that isn't physically within the engine, and the engine has to be online. So that's I suppose maybe that's where they're covering their backsides.
Yep. All right. Next question is, how does it work, or do you know anything how it works with other streaming technologies like Infosphere, Kafka, or anything else?
No, I have a customer that uses I think it's called SQLDR or something like that, and they use change data capture functionality to capture the data. They pull it up into their app. They do some stuff with it. So they basically use this logic to capture information and stream it out into another database. They take the SQL and convert it into something that's appropriate for the other end, and various other things that make life a little bit easier, but they're using the underpinning change data capture functionality. They need the table definitions, so you can't just say, replicate this database to this other database and expect it to create all the tables for you, because CDC does not give you that DDL. So you can create the table in Informatics, create the table in something like a spreadsheet, Oracle or DB2, and then use SQLDR to push the data into that table. And you can do that bidirectionally. But obviously, we're not using CDC to push it back into Informatics. We're just using it to push it upstream. And it works reasonably well. But it's, I think SQLDR, it's a 6-figure ticket, so it's not a cheap thing. But you can integrate CDC with the audit logs Mike were talking about earlier, and things like iWatch, and you can have a complete visibility into everything that's happened across your system. I like iWatch, but using CDC, and I said the auditing from Mike, you can go and find out from the auditing. We can tell when somebody deleted something or created something, and then from a mixture of CDC or something like DBVoyeur, you can go and find out what they did. But the demo code they give you is quite good. It gives you all the basic building blocks. You just have to work out what you want to build.
All right, thank you. Anyone else have any other questions? Okay, great.
Stunning silence.
Yeah, no. So Paul, your information is on the slides.
Yep.
So if you're good with me putting the slides up on the website after, your info will be there. So if folks are watching on a replay, it's going to be in here, and we'll have more information on WAIUG.org. So I'm going to have you stop sharing here real quick.
Yeah, I'm trying to work out how to do that. You might try and do it from your end, because I can't see a not share button.
Yeah. So just so it's up here on the end of the webcast, so if anyone's watching the replay, or hopefully lots of people are watching the replay, but if you're watching the replay, here are the standard sites that were referenced. So you have it there for information. I'll be putting up more of the information, and once they're ready, the replays on WAIUG.org. I believe, and Lester tell me otherwise, that we may link to it from IUG.org as well.
Yes.
Okay.
And replays will probably be available by Monday.
Okay, great. And wanted to include a link there to the certification information that Stuart referenced. So it is there. Please go check that out. Want to thank all of our presenters again. Really, really appreciate this. They are all volunteering their time, their expertise for the larger, Informix community. Really appreciate everyone that has been involved. If you are watching this on the replay, you were missing quite a bit of back and forth discussions and, friendly banter in chat. So certainly worthwhile to get these live when you can, to be more involved. And I think that is about it. So again,
Your last question, Tom.
oh,
Really
thank you,
important.
thank you. And I completely forgot to add it to the slide, and I am sorry.
No, it's there on the slide.
Oh, duh. So question in general here, if folks want to add into the chat, I was looking at the slide and didn't even read that part. If folks want
I could suggest, if people could just put in person or virtual in the chat, one word, so that we know what you would prefer. Like Mike just said in person. And Rhonda, if you can collect that. Rhonda said in person. Perfect.
And if you are watching a replay, if you just drop a note to anyone at the IUG board, or is info@iug.org active?
That's a Rhonda question.
All right, Rhonda may have stepped away or be muted. At any rate, if hop on the IUG site, if you're seeing this in as a replay, let them know what you think. This is us as a community soliciting response back, and we want to know: do you want virtual? Do you want in person for the next conference?
There is a board meeting next week, and we need to know that by then.
Okay, great. And again, with the WAIG, we'll be planning another one of these probably fall timeframe, fall, early winter, sort of before the end of the year. If you'd be interested in speaking, or if you have ideas for a topic you'd like to see, reach out, let us know. We're all pretty available. So really appreciate everybody.